Yes, yeah. Good evening all. So in the last class, I was discussing about evaluation. What is PySpark, right? PySpark, need for PySpark. Yes. Mainly designed for dash up. Okay, map is Spark and pick. So these notes I'll be forwarding, right? Your yes. Motivation towards Spark. Spark has sorted 100 TB data using 206 nodes in 23 minutes. Previous world record by using Hadoop MR cluster using 72 minutes, right? Resilient distributed data sets, RTDs. PySpark data objects are called RTDs. RTDs subdivided into partitions. RTD partitions are distributed across multiple ramps of multiple worker nodes. Here, the advantage is huge data sets also can be loaded. RTD programming style is data flow. Data flow is sequence collection of pipes. In a Spark, data flow is executed. See, pipe is any data operation. Data operation means loading data, transforming data, merging data, filtering data, and sorting data. Data flow is executed in sequence, RTD by RTD, one after the another, right? With in memory. Yes. 1 second. Yes. So pipe is any data operation, loading, transforming, merging, filtering, and sorting. Yes, in Spark, data flow is executed in sequence RTD by RTD. Why RTD by RTD, one after the other? The output of one RTD is given as input to the next RTD. RTD by RTD, yes. With in-memory computation, right, and persistence feature. If RTD has got 30 partitions, all the 30 partitions are executed in parallel. Okay. Then all the 30 partitions can be executed in parallel. Yes, okay, all this. Okay. Observe this. Yes. On a RTD, yes, observe on a RTD, two types of operations can be performed. Two types of operations can be performed. On a RTD, two types of operations can be performed. First one, transformations. Second is actions. On RTD, two types of operations can be performed. Transformations, actions. Transformations mainly are of three types. Transformations. Mainly there are of three types. Transformations mainly of three types means right. First one, each element of transformation, each element of transformation Second is like filter transformation. Each element transformation, filter transformation. Aggregated transformation. Each element transformation, filter transformation, aggregated transformation. Yes. Each element transformation, filter and aggregate. Each element transformations, each element transformation. So, for example of each element transformation, there are some built-in functions like map, flat map for it. Map, flat map. Yes. Example here, transforming each element, transforming each element. For example, name, assume each element means each name. Transforming each name, each element name to start with. To start with uppercase character. Transforming each element name to start with uppercase character and remaining in lowercase. Only the first character in the uppercase. To start with uppercase character. Means if you have got 1 lakh employees, if you have got 1 lakh employees, right? All the 1 lakh employees, first character should be in uppercase, remaining all in the lowercase. Means each element transformation we say. For example, I want to add increment. I want to add increment to all the employees. For example, I want to add 5,000 to all the employees. That is each element transformation. I'm adding some amount to each and every element that we call it as each element transformation. Filter transformation, filtering based on city. Filter based on department, filter based on salary. So here we have got some built-in inbuilt functions like filter. Filter function is available. Filter by range. Filter by range. Filtering based on condition. Filtering based on condition. Filtering based on a condition, right? Filter by range. Next is aggregated. Okay. Example. Filtering based on city. Next, aggregated transformations. Aggregated transformations, right? Grouping, group by. Example, right? Example. group by city.
Sir, what do you mean by transformation here? Data transformation, you mean?
Yes. So transformations in actions, two types of operations you can perform, right? Transformations and actions. So 1 second. Transformation and RTD. Transformation on a RTD results in RTD. Another RTD. Transformation on RTD results another RTD. Action on RTD. Spark object you get. Spark object you get. Action on RTD results Python object. Results local object. Local object means if you are using language Scala means Scala object. Python means Python object. Observe this, if you apply any transformation, here the transformation can be, here the transformation can be what do you mean by transformation can be? Filtering, transforming, merging, grouping. Transforming means what? Here just I said transform each name to start with uppercase character. Filtering, transforming, merging, grouping, sorting, all this. So if you perform any transformation, right, on an RTD, the results on another RTD Spark object. Result is also an RTD. Action on an RTD results a local object, Python object. Try to understand this. If you are applying a transformation on an RTD, output is an RTD. If you're performing action on an RTD, you will get a Python object or local object. You won't get Spark object. Spark object means what? RTD. Python object means lists, tuples, variables. Understood, right? Transformation means inbuilt transformations we have got. We have got many inbuilt. Map is one inbuilt transformation. Flat map is one inbuilt transformation. Filter. This many functions are available for transformations. Many functions, inbuilt functions are available. We'll be discussing. We'll be discussing all the inbuilt transformations of Spark.
So basically, we will be doing the action operations, right? Because that's so for Python object, right?
So actions means if you are not performing an action, first thing is your data flow won't execute. Yesterday I was saying if action performed, then only the data flow executes. Otherwise, data flow is not executed. Okay. Transformations, three types. Each element, filter and aggregated transformations. Say aggregated transformations. Group by city. Group by department number. Example, right? We have got a group by key. Group by key. Reduce by key. There are some inbuilt functions. Group by key, reduce by key is available, right? Group by key, reduce by key. So these are about transformation. If I discuss, I'll be discussing practically, right? That one by one transformation, what it is going to perform, what output it is going to get. Compulsory in Spark, that in PySpark, right? You need to know what output you are going to get. You need compulsory every line, what output it is giving and what will be the input to the next flow. Next is actions. If I talk about actions, when an action is performed, right, on a RTD, when an action is performed on a RTD, then only, right, the data flow. When an action is performed on a RTD, then only the data flow will be executed. From the root RTD, right? When an action is performed, then only the data flow will be executed from the, then only the data will be executed from the root RTD. The following are some of the actions. Okay, first one, collect. Collect, right? Whenever you say RTD.collect, RTD.collect, for example, RDD8, for example, RTD4.collect. As I said, right? Then the entire flow will be executing from RTD1 to RTD4. Action, this collect is one of the action, right? So what it performs, it will collect all the partitions. It will collect all the partitions data of from different slave machines into client machine. It will collect all the partitions data from different slave machines into client machine. Okay, example, right? RTD.collect. Count. Counts the number of elements in a RTD. Counts the number of elements in a RTD. RTD.count. RTD.count. Means if there are 5 records, RTD.count returns 5. Next, these are all the actions. If you say RTD.collect, the entire data flow executes. RTD.count also, it executes the entire data flow. Take is there. We have got to take off in.
Then it might be a performance issue, right, sir? If you use this kind of function, because the entire data flow will be executed, right?
Yes, whenever you perform action, what are the different types of actions means? Examples I'm saying. So if you perform any action, right, the entire data flow. So just not data flow won't be executed automatically. To execute the data flow, compulsory action has to be performed. Takes first n number of elements. Takes first n number of elements in order. So it is similar to limit in SQL. Similar to limit in SQL. Example, RTD dot take off 10, RTD dot take off 10, right? Yes. Means takes the first 10 records, means takes the first 10 records. Means takes the first 10 records. If the partition one is having only 5 records. Assume if the partition one is having only 5 records, then it takes it takes 5 records from partition 1, 5 records from partition 2.
And sir, if there are 20 records, then it will only tell first records.
Yes, RTD take off 10 means it takes first n number of elements. First n number. For example, in a college, 60 students, for example, in a 60 students, I want top 10. So ranks are given 1, 2, 3, 4 up to 50 ranks. So I want first top 10, the college rankers. RTD take off 10 means first 10 it takes. Okay. Next, one more action like save as text file.
Sir, here you said like 5 records from partition 1, 5 records from partition 2. If only having the 5 records, then how it would be, because it will be a 10 records only, right? 2 partitions.
So if you have only 5 records, then only 5 takes. Means if, for example, RTD take off 30 if I say, but if you got only 20 records, means whatever available only it can take. Means just like in SQL while creating table, you will give employee name. The size 30 will give. Means up to 30. Here also take off 10 means first 10. If 10 are available, takes first 10. If not available, how many available it takes?
If in the partition 2 also, if the data are not sufficient, then it will jump to the partition 3 and take the data, right?
Yes, yes.
Got it. Thank you.
If you've got multiple partitions, right? From multiple partitions, it will take.
And sir, if in the partition one there are 10 records, then it will take the data from that one only, and it
One
will
not-
not go to the second.
Yes, yes. When it goes to the second partition, if those may 10 not sufficient in partition 1, they're not available in partition 1, it goes to partition 2. And it won't take all that. It will take 5 records. Save as text file means storing the results. Into HDFS file. Storing the results into HDFS file. Okay. So these are some of the examples of some actions, right? Now, for example, right, RTD creations. Observe R1 is an RTD. RTD1, how this RTD1 is created? Using Spark context dot text file. Spark context dot text file. The HDFS file path. So the file path, just to give the file path where the file is available. Using Spark context, if you are loading a file, then RTD is created. When the first RTD is created, how the first RTD is created means using Spark context if you are loading a file.
That file should be the text file in the HDFS or other also.
Yes, HDFS text files will be there. XML files will be there. JSON files will be there. I'll be showing how to work with different files. So now RTD2, how RTD, okay. On this RTD1, I performed a transformations. What transformation? For example, here, transformation like map. RTD1.map. And okay, map, you are doing something. Whenever you are performing something on RTD1.map, the result, whatever you get, what you get? Spark object or Python object. On a RTD, if I am performing a transformation, what is the result?
Another RDD.
RTD2 is created. On RTD1, if I'm performing any transformations, I'll be showing you the inbuilt transformations one by one in the practicals. So any one inbuilt transformation, if you're applying on this RTD, the result is an again RTD. Now, on this RTD2, again, I'm performing one more transformation, this time filter transformation. What is the result? Spark object or Python object?
Sir, every time we need to assign to the new RDD.
RDD3 is created. See, on RTD1, RTD2, if you are performing filter operation, do you think RTD2 gets modified? No. RTD2 output you are taking and you are filtering. And for example, in RTD2, you got 100 records. From this RTD2 100 records, the 100 records dot filter Hyderabad, only Hyderabad city employees only I want. Where city equal to Hyderabad, only filter city equal to Hyderabad I get. Means from this 100, how many employees belongs to city Hyderabad? Some 20. Means in RTD3, how many records? Hello? In RTD3, how many records?
will be 20 records.
20 records. In RTD2, 20 records. 20 records. In RTD2, 100 were there. After filtering, you got 20. And again on RTD3. Again on RTD3. On RTD3, you perform some operation like flat map.
Sir, here RDD1, RDD2, RDD3, are these the kind of variables or collections type which get created after performing the transformation?
It's like a collection type.
Okay, okay.
So if you want RTD1.count, it shows how many records are there. It gives the count. RTD1.collect, if you say, it will how many all the records to display. How many are there? It will collect and displays.
It means for the collect, it will display the records, total records.
Yes. Now RTD4 you got. On RTD4, observe carefully. On RTD4, I'm applying reduce by key. I'm applying a reduce by key. Or okay, sorry, control set. On RTD4, I'm applying group by key. Grouping operations, group by key. There's a built-in functionality, group by key. RTD5 is created. RTD5 is created. When RTD5 is created, on RTD4, right? Group by key.
And sir, RDD4 will be in the memory or not? When file gets created.
Yeah, just next after this, I'll be showing you step by step what is happening in each line.
And
RTD.
here it is parallel operation or what?
Which one?
The RDD1, RDD2, this transformation are doing in the parallel or
Here,
one after one?
RTD2 output it is taking and filtering.
Okay.
Then RTD3 is created. Without RTD2 execution, see RTD3, how you got after filtering RTD2 only RTD3. Without performing this operation, you won't get RTD3, right?
Okay, this is the DAG example, like direct acyclic graph kind of thing.
Directed acyclic graph, DAG model.
Okay, got it. Yes.
So here, the output of RTD1 will be input to RTD2. The RTD2 output will be RTD2 output is taken, filtered. Now RTD3. And RTD3 output you perform as an input. Right? So output of one will be taken as input by the other.
The filter operation can be parallel processing, right?
No.
I mean,
No.
I mean that RDD will distribute it to multiple nodes, right? RDD2 while performing filter.
RTD2, right?
Yes.
RTD2, okay. RTD2 dot filter. So all the RTD2 partitions are distributed across multiple nodes, right? Now parallelly, it is going to execute and filters all those. See, for example, I want only Hyderabad city records, right? In such case, there are 10 node slaves are there, 10 systems are there. 10 systems, the data is spread across. In every system, only the first system, how many Hyderabad records, second, how many Hyderabad, third, how many, that result it gives. That total result will be collected by RTD3. RTD3 collects it as input.
And within RDD, that operation will be parallel only. I mean, distributed across.
Yes. If RTD1 has got 40 partitions, all the 40 partitions will be executed parallel. But two RTDs can never execute in parallel because RTD1 output is given as input to RTD2. See, initially there is only RTD1 only available. From where you got this RTD2 from? From RTD1, you understand this? Only RTD1. How you got this RTD1? Whenever you loaded a file, then RTD1 only created. Only that was available. From RTD1, I performed some map operation, mapping each employee name to starting with uppercase. That now RTD2, all the 1 lakh employees which are present, right? With where the first character in uppercase, that is mapped. and filtered, you will get some output. RTD2 got generated from RTD1, RTD3 got generated from RTD2, RTD4 got generated from RTD3. So in that RTD5 from RTD4. And here finally I'm saying RTD5 dot collect. RTD5 dot collect. Store it. RTD5 dot collect means RES I'm saying. RES equal to. Now try to answer RES. Is it a Spark object or scale object?
Scalar.
Python object.
Okay. Yes. So see that flow, right? This is the entire flow. RTD1, RTD2, RTD3. Yes.
Sir, that RES will be the Python object or
Yeah. RES. What is the collect? Is it a transformation or action?
Action.
Action.
RTD collect is an action. When action applied on RTD, will you get a Spark object or Python object?
Python object.
Yes.
sir, is there
RES.
any key to identify whether that is a action object or a transformation object? Hint.
See one thing, okay, I'll say in the coming examples, you will try to. So you need to know all the actions. All the actions. Collect is an action, count is an action, take is an action. If these actions, if you're applying on RTD, the result you are going to get is. So in the practical part, what we discuss, along with this, immediately you will get that response. Here it will say RTD on Python object. It will display that. Okay. So you need to clearly say whether you are, when you are applying something on an RTD, first you will know that whether it is a transformation or an action. Yes. When you are applying something, right? When you are applying something on a RTD, what you are applying, you will come to know whether I'm applying transformation or I'm applying action. So if transformation applied, you will come to know RTD I'm going to get. Action applied means you are going to get Python object.
So is it not possible to, let's say I collect at one step and then store in another RDD and make use of that? So I perform 2-3 steps of this transformation, and then I collect and then
Yes.
put that result into an RDD,
One second.
another RDD, and then use it. So in the, or it is abundant. We cannot collect and put it into an RDD.
You can do that. So your query is RTD 1, 2, 3. These 3 steps you will perform, and you will say RTD that collect. You will get the output. The output you want in another RTD you are saying.
Yes, yes.
Then we have got a concept called parallelizing. To convert a Python object to Spark object, we need to parallelize.
So how, okay, so how do we differentiate then? RES is a Python object, or RDD isn't an RDD then, if it is possible?
So how you are going to means well, so in Python, you need to know about the transformations and actions.
Mhm.
When you are
Yeah,
applying something, you need to know what it is, what you are applying. Transformations means what? Transformations means what? Like filtering, merging, grouping, sorting,
Yeah,
all
any
this
modification of data.
modification, filtering, transformation. These operations you are performing, right? This is nothing but
Right.
transformations. Whenever you are applying those things, right? Another RTD is created.
Yep.
Okay. So here RES. Here RES is a
Sir, I have a RDD, Python object. From the Python object, can we convert into the RDD object?
yes, Spark object you can create. RTD.
How we can, how can we done that actually?
So we'll be doing, we have got parallelizing, we say, right? Parallelizing.
Okay.
What do you mean by parallelizing? Is converting a local object. Converting a local object, right?
Okay.
To
So
Spark object.
even vice versa is also possible, right? From RDD to Python object. I mean,
You need to
RTD to
apply
RTD to
X.
again, just you perform some action on it. You will get collective suggest.
okay.
You will get Python object. So now,
Sir,
okay.
here
Okay.
we are not going to store the data in database, right? Everything will be in the
Memory.
HDFA.
So I what a query, right? So yes. Here currently, how many RTDs? How many RTDs are in RAM?
Five RDs.
Currently, how many RTDs in RAM? Yes, someone said, right? Mahesh.
No.
None. Zero. No RTDs in the RAM. Currently, how many RTDs in RAM means no RTDs in the RAM. Zero. When action is performed, one by one RTD, one by one RTD will be loaded. One by one RTD will be loaded and computed. And the previous RTD gets removed. The previous RTD
When
gets,
action is only performed or action or transformation is performed?
when action is performed only, one by one RTD will be loaded. Generally, you perform all your transformation here. Finally, you will say action. If you say action only, then this entire data flow, right, executes. Once you perform action on this RTD5, then that execution starts from RTD1 to RTD5, and final RTD5 output is collected. That is what happens. Until you won't perform action, this flow won't be executed. When action is performed only, one by one RTD will be loaded and computed, and the previous RTD gets removed.
So when the RDD will be in RAM?
Once
Then-
the execution is yes, I'm coming. Once the execution is completed, then the last RTD also gets removed.
Means, sir, when we create that at the time of the creating that Python object, at that time, this 4 RDD will be in the RAM. And when that
So-
object
So observe this diagram for your understanding. When the RTDs are loaded into RAM, means once action is performed, one by one RTD. First, RTD1, observe this RTD1. RTD1 is there. RTD1 loaded into RAM. Loaded into RAM. The output of it as taken as input by RTD2. The output of it as taken as input by RTD2. Assume that you got some 100 records in RTD2. On RTD2, you perform when RTD2 is ready. When RTD2 is ready, RTD1 is removed. On RTD2, you perform some filter operation. RTD2 filter. RTD2 dot filter. You got RTD3. The output of RTD2 is taken as input. Here in RTD2 100 records. In RTD3, think that only like 20 Hyderabad records are there. What is that? Only 20 records here. In RTD3, only 20 records as the output. And RTD3 again, when RTD3 is ready, RTD2 gets removed. Again, and RTD4 on this RTD, next from RTD5. When RTD4 is ready, RTD3 gets removed. When RTD5 is ready, RTD4 gets removed. Once the final output is collected, RTD5 also gets removed. Means don't think all the 5 RTDs will be loaded at a time. No, all the 5 RTDs won't be loaded at a time. RAMs, that much of RAM capacity won't be available, right?
So there is one question.
Yes.
So let's say I am doing an operation of filter, and because generally we reuse in multiple places doing that. So here I'm doing a filter, and then the RDD is vanished, it is removed, and then if I need similar kind of operation for another case, then I have to create.
Why you will remove RTD whenever you are
with-
performing?
Yes, so here in the flow, after collect, which is an action, and the result is stored in RES, then all the earlier RDDs are removed.
Yes.
Yeah, so just my curiosity was the same filter result I want to reuse in some other place, maybe in the flow.
Then RTD3 you persist it. It won't be removed from the RAM.
So there is some functionality to persist it.
Yes,
Okay.
very simple right here. RDD1, RDD2, RDD3, RDD4, RDD5. This output as input to this output as output. When this is ready, this gets removed. When this is ready and completed, this gets removed. This gets removed. When this is ready and completed, this finally, once the output is collected, that pi also gets removed.
So there is any persist function is there to persist any RDD?
Which one? R3, if you want to persist, we need to say
Yeah.
R3 dot persist.
Okay.
So it will persist
Thank you.
for that session, na?
Yes. So yes, this is what R3
And
dot
by
persist.
default, it is unpersisted.
So 1 second. So here, yesterday I was saying, right, two situations. I was just yesterday we have discussed these things. Two situations where RTD will be removed from the RAM. What are the two situations where RTD will be removed? Means whenever next RTD is ready, previous RTD gets removed. When action or execution is completed, then the last RTD will be removed. And I'm sorry, two ways to persist in RTD: RTD dot persist, RTD dot cache. So this persist will make use of all the persist means RTD dot persist forcefully and when session is closed when server shutdowns. What is lazy evolution in PySpark means executing the data flow on demand by performing an action is called as lazy evolution. Okay, fine. Clearly, I'll just show you the steps, right? Steps in RTD computation. Observe this. Now, steps, what all we have discussed, right? Up till now, steps in RTD computation. Step one. Step one. Initially, all the RTDs. Initially, all the RTDs. Initially, all the RTDs are declared. Initially, all the RTDs are declared. They are not stored anywhere. They are not stored anywhere. Just 1 second. Sorry, is my voice clear now? Can anyone please confirm?
Yes, sir.
Yes, sir.
Steps in
Yes, sir.
OTD. Yes, steps in OTD. Initially, all the OTDs are declared. They are not stored. They are not stored anywhere. We load and execute. We load and execute them on demand. We load and execute them on demand by performing an action. We load and execute them on demand by performing an action. This type of evolution is called as lazy evolution. Step 2. Active evolution means when loaded immediately it executes when declared, executed when declared, right? Spark supports only lazy evolution. Whenever required, we execute, right? Yes. Step 2, right? When action is performed, right? What happens? Flow execution will start. Flow execution will start from its root RTD. When action is performed, flow execution will start. Flow execution will start from its root RTD or available RTD. When action is performed, flow execution will start from its root RTD or available RTD. That is when action. Step 3. During flow execution, right? Yes, during flow execution, each RTD partition, right, will be loaded into RAM, and computed. Will be loaded into RAM and computed at RAM. During flow execution, each RTD partition will be loaded into RAM and computed at RAM. Step 4. Once RTD computation is completed, once RTD computation is completed, once RTD computation is completed, it waits for its next RTD. It waits for its next RTD of the flow. It waits for its next RTD of the flow. it waits for its next RTD of the flow. If next RTD is ready, previous RTD gets removed. Previous RTD will be removed. Unsorted, it waits for its next RTD of the flow. Right. If the next RTD is ready, the previous RTD will be removed from the RAM. Previous RTD will be removed from this RAM. Okay, this process continues. Till the action is completed. This process continues till the action is completed. Right. When action is performed, all RTDs, see, once RTD, see, during flow, all RTD partitions will be loaded into RAM and computed at RAM. When action is performed, all RTDs are stored and computed at Spark side. That is in Spark cluster machines. In Spark cluster machines. In Spark cluster machines. But the final result, right? Which is produced, final results, which is produced after final result, which is produced after performing action. After performing action. But the final result, which is produced after performing action. Is stored in client machine. Is stored in client machine. Client means what? The machine from where? Client means the machine from where we are submitting. Client means the machine from where we are submitting. They are submitting the job, right? The machine from where we are submitting the job. Machine from where we are submitting the job. Okay. Now step 6. During the flow execution,
Sir, here when you say Spark cluster machine, it means the Spark node RAM, right? Because in the step number 2, step number 3, you mentioned partitions will be loaded into the RAM and computed at RAM.
Which
So
RAM
in the
is
step number 5,
in
you
the
mentioned Spark cluster machine.
So in the Spark cluster machines will have RAM, right? Into the RAM
Okay.
it will be loaded. Yes. Step 3 means into RAM. RAM means which RAMs? Cluster machines RAM, right?
Yeah. Can you mention that there is Spark cluster machine RAMs?
Will be loaded into RAM into each RTD partition will be loaded into multiple RAMs.
Okay.
Each RTD partition loaded into
And there will be a file, right, where we are going to define all these RAMs, configuration of the RAMs and all.
each RTD partition will be loaded into RAM of cluster machines.
So when the job runs, we have to define these values somewhere, right? RAM values and memory values somewhere in a file.
And computed at RAM. So those things, right? So yes. So before we go with this, right, we will be providing that RAM, right? Distributed RAM. For example, if each RAM of 16 GB, if you've got some 100 systems, what is the total RAM? 1600 GB, right? Means what is the distributed RAM capacity you are providing, right? So how much of the data can be accommodated by your RAM? So that everything before we go with this project, right, we need to decide how many cluster machines and what is the RAM capacity, what is the RAM capacity to be maintained for accommodating the data, right? During the flow execution, right? The RTD, now the RTD, which is commonly used, right? Which is commonly used by used by many flows. During the flow execution, the RTD, which is commonly used by many flows, will be persisted. Persisting means making the RTD available in the RAM. Persisting means making the RTD available in the RAM. So the other flows can reuse executed transformations. Can reuse the executed transformation. Finally, the RTD is stored in RAM. Will be unpersisted. Finally, the RTD stored in RAM will be unpersisted. Finally, the RTD stored in RAM will be unpersisted when session is closed. Or when server shutdowns. Or forcefully. we can unpersist. Finally, the RTD stored in RAM will be unpersisted when session is closed or when server shutdowns are forcefully, we can unpersist it. Okay, so these are the steps involved, right? Steps in RTD computation. Initially, all the RTDs are declared, then they are not stored anywhere. We load and execute them on demand. That's action is called as late. When action is for full execution will be started from its root RTD. During flow execution, each RTD partition will be loaded into RAM of cluster machines and computed. Once RTD computation is completed, it waits for its next RTD. If next RTD is ready, previous RTD will be removed from the RAM. This process continues till the action is completed. When action is performed, all RTDs are stored in computed Spark site, but the final result, which is produced after performing action, is stored in client. Client means from where we are submitting. During the flow execution, the RTD which is commonly used by many flows will be persisted, means making the RTD available in the RAM so that other flows can reuse the transformation. Finally, the RTD stored in RAM will be unpersisted, right? Steps in RTD computation. What is lazy evolution? Ways to unpersist RTD. Ways to persist an RTD, where RTD will be removed from the RAM. Ways to situations where RTD will be removed from the RAM, right? So what are the two operations we can perform, right? What is it? Transformations and actions. Transformations and actions. And what is how this RTD are distributed and stored across, right? Yes, this RTD computations. So how to create an RTD, right? Three ways are there. I'll be discussing, right? Three ways, right, for creating an RTD. First way is, I said here, first way is here I discussed, right? Whenever you're loading a file, then RTD is created. Whenever you're loading a file, then RTD is created. That is one way. Second way is, once you got a Python object, that Python object you can convert it to Spark object by parallelizing, right? Yes. That is second way. Third way is already we have discussed. On a RTD, if you perform any transformation, the result is also an RTD. Three ways, right? First way is whenever you load a file, and second is on a RTD, if you perform any transformation, the result is also an RTD. Third way, once you got a Python object as output, that if you want Spark object RTD, then parallelize it, you will get the output also as an RTD, right? These are the three ways. Once again, I'll discuss it in detail, different ways of creating RTDs. And one thing is left out, like fault tolerant model, right? Means when this computation is going on, suddenly if any machine goes down, or once machine or machines goes down, right, then there will be a data loss. Then how Spark overcomes these things, right? It has got powerful fault tolerant model. It has the capability of rebuilding the lost partition, and it can create and recomputes it again. So different cases I'll be discussing, right? In fault tolerance also, case 1, 2, 3, 4 cases I'll discuss, right? In the fault tolerance model. Fine. So for software, right? Yes. 1 second. So for software, for the practicals next week, I'll be going with the practical part. So I'll forward you a software to your Google Drives. People who are already they're working in Hadoop, right? The same software you can use, but I'll provide one RAR file, Xubuntu VMware.rar file. So already doing practicals of Hadoop, right? In the same thing, Spark, PySpark, Spark with scale, everything you can perform. X Ubuntu VMware.rar. One RAR file, I'll say, just extract it. It will be of nearly like 5 GB. It will be nearly first download it and extract it. Right click and say extract. After extracting, you will get VMware software that you install it, normal installation. I'll provide two files. One is this, second is keys, right? VMware software, install it. Finally, while installing, it will ask key. Any one key you can take from there and install it. Yes. Now VMware installation. Later, I'll just show you in the next week, right? Just download, extract, and just install this VMware. So those who are already doing this Hadoop practicals, right? You can use the same thing. In that PySpark, Spark with scale, everything you can perform, right? So try to get those anyone, right, who didn't get enrolled for getting the software, for getting the videos to your Google Drive, for getting the notes, and to get added into the WhatsApp group, right? Get enrolled, right, everyone. So if anyone for joining for PySpark, right, get enrolled, right, for PySpark. You can see that.
Yeah, sir, can you just put the notes also in the Google Drive, because we already have access to the Google Drive, so can put the notes in the Google Drive.
Yes. Yeah, notes I'll be forwarding you, right? Yes. Fine. So next week I'll be going with the practical part. Before I go with just, I'll take the Python syntaxes. Just I'll brief you about the Python syntaxes, like collections, functions, everything. And before I go with the practical part. So one thing is fault tolerances and persistence options are there. Persistence options, memory and disk only. If memory is not sufficient, where it can be persisted, means in disk. Okay, those things. And this clear notes I'll be providing, right? So here, this is the entire thing what we have discussed till now. This entire document I'll be forwarding you, right? Yes. Okay, fine, regarding this price. So the next week, next Saturday, the link will be changing, right? So you'll be getting a new link to your mail IDs. So try to get enrolled, and after enrolling, right, don't forget, if you have not got that link, you can just contact the online team. Yes. Okay, a separate WhatsApp group for this PySpark will be created, right? And I'll be adding you all those people. In the next Saturday, I'll be creating a separate WhatsApp group for PySpark. Okay, fine. So I'm stopping for now, just to go through all these notes. So next week we'll go with the practical part.